Spontaneity. This will determine if a reaction is going to happen or not. So we want to know, will a reaction happen, and can we make it happen if not? So a spontaneous reaction, spontaneous, random, reactions that will happen. A non-spontaneous reactions will not happen. Even if they do happen, we can't say how fast they will happen. There are two factors that influence the spontaneity of it. That is enthalpy, or delta H, heat, and entropy, or S, which is our disorder. So again, there are two factors. Let's talk more about them. And exothermic reactions tend to be spontaneous. This is at a negative delta H. This is where our reactants are higher in energy than our products, as we have a hot or heat coming out, so therefore it feels hot. Remember that a positive delta H is an endothermic reaction. We also want the reactions where entropy of the products is greater than the reactants, and these tend to be more spontaneous. So therefore a positive S has more disorder. So a change with a positive entropy and a negative enthalpy is always spontaneous. A change with a negative entropy and a positive enthalpy is never spontaneous. There is a page in your guys' book that also has some more information about this. So some other possibilities. Temperature can affect entropy. So at higher temperature, you have a higher entropy. You have more disorder. You are more likely to be a gas, or those gases are moving at more disorder. For an exothermic reaction with a decrease in entropy, like rusting, so you have E. So spontaneous at low temperature, and it can be non-spontaneous at high temperature. This is where it's enthalpy driven, delta H driven. So if it's entropy driven, therefore it's spontaneous at low and non-spontaneous at high. So other possibilities could be an endothermic reaction with an increase in entropy, like melting ice. So spontaneous, it will be spontaneous at high temperature and non-spontaneous at low temperatures because it's entropy driven, S driven. So the way we get this is we actually get an equation to determine if it can be spontaneous or not. This is called Gibbs free energy. So Gibbs free energy includes our entropy, our enthalpy, and temperature all together. So the energy, Gibbs free energy is the energy to do work is the change in the Gibbs energy. So we have delta G as our Gibbs energy equals our enthalpy minus the temperature times our entropy. And our temperature must be in Kelvin. And let me just make this clear. It's just delta H degree minus T. That it looks kind of like there's a lot of minuses here. So all spontaneous reactions will release free energy. So therefore, delta G has to be less than 0 for it to be spontaneous. It has to be negative for it to be a spontaneous reaction, and therefore your equilibrium will be much greater than 1. And then here, your delta G must be less than 0 for a non-spontaneous reaction, and your equilibrium will be less than 1. And then delta G, if delta G is equal to 0 for a reaction, it just means that is at equilibrium, and it won't react, and it won't appear to react in any way. So here's kind of a good summarization. So we have our Gibbs free energy equation, and we want to know if it'll be spontaneous or not, depending on our delta S and delta H, our entropy and our enthalpy. So if our entropy is positive and our enthalpy is negative, our Gibbs energy will always be negative. Therefore, it is spontaneous at all temperatures. If we have a positive entropy and a positive enthalpy, we don't always know what could happen. We're not sure. We know, though, if it's at a high temperature, this is therefore entropy driven, and it will happen at a high temperature if they are both positive. If they are both negative, it again could happen. This is going to be happening at low temperatures, so it's enthalpy driven. And lastly, if it's negative and positive, it'll have a positive Gibbs energy no matter what. So not at any temperature will it react. It will be reverse. The reverse reaction is spontaneous, so making the reactants will be spontaneous, but not the products. Well, that's it for Chapter 18. Please let me know about your questions. Your test is Monday and Tuesday next week.